Hey everyone, I hope you had a good weekend. We're going to pick up on the angle stuff we worked on Friday by building in and start talking about parallel lines and transversals. Parallel lines and transversals are a big part of what we do in algebra because they, in a lot of instances, form a lot of the shapes we start working with. So, a transversal, that's the most important word we got to remember. That's a line that intersects two or more other lines. In our diagram, we have three lines there. We have line T, line M, and line N. Line T is the transversal because it crosses over M and N. There's no real relationship yet between M and T or N and T because we can't say that they're transversal to T yet because there's no other line kind of in conjunction with T there. So they have to cross two or more other lines. What they do is they create angle pair relationships. So they call these six relationships corresponding angles, interior angles, alternate interior angles, consecutive interior angles, exterior angles, and alternate exterior angles. I just realized too, they create vertical angles because we learned that on Friday that cross lines, opposite angles are vertical. I didn't list those here because we already learned them. But we're going to go forward from here now and talk about all these different types of angles. So corresponding angles. They're angles that are in the same position relative to the transversal and intersected line. Interior angles. So we're kind of talking about the corresponding angles are on the top or bottom of one of the lines that intersected, and then the right or the left of the transversal. So kind of in my example here, angle 1 and angle 5 would be the corresponding angles because they're in the same relationship relative to the line of the transversal. Interior angles, those are always the angles that are between the two lines that are being intersected. So all the angles between M and N, they're the interior angles. Alternate interior angles, they're the lines that are in between M and N, but they're on opposite sides of the transversal. So they're not on the same side of the transversal. One's on the right, one's on the left. And it's not, they're kind of opposite lines too. So like 3 and 5 are the opposite interior angles. It's not 3 and 4. Consecutive interior angles, those are the angles that are on the transversal on the same side of the transversal. So 3 and 6 in our example here would be the consecutive interior angles. Exterior angles, just what you think, they're the angles that are outside the two lines that are being intersected. So they're the other 4 angles of the 8 angles that are created. And then alternate exterior angles are the angles that are outside of the two lines, but on opposite sides of the transversal again. So just like alternate interior, there are alternate exterior. All right, so let's take a look and kind of identify it again. So we talk about the corresponding angle pairs. They're the pairs on the same relationship, same area, same angle. So we're looking at, for corresponding, we have 1 and 5. We'd also have 3 and 7. They are the corresponding angles. Does that make sense to everyone? Right. The interior angles are all the angles on the inside, so that's 3, 4, 5, and 6. I jump out to exterior angles. Those are all the outside ones. I actually just realized I have a tempo. They're 1, 2, 3, 1, 2, 7, and 8. Those are the exterior angles. That makes sense. Okay. Alternate interior, kind of like the ones you can cross, kind of cross multiply kind of thing. Those are alternate interior. So 3 and 5, 4 and 6. Consecutive interior will be 3 and 6. These are the consecutive interior. And then our alternate exterior will be, we'll kind of highlight those ones up a little bit. Be 1 and 7, and then 2 and 8. Does that make sense? It's a big relationship we have. We're going to learn a lot. We're going to do a lot with this stuff. It'll be reinforced all the way through the rest of this unit, I think, as we kind of go through it. But then you'll start seeing it in other things when we start working with some triangle stuff, and things like that. All right, let's move on. We have an example now. We are asked from the diagram to classify four pairs of angles, whether they're alternate interior, alternate exterior, corresponding, or consecutive. So I'm looking for angles. A is angle 10 and angle 16. The complicated part of this is there are really four intersecting lines, so there's really 8 sets of parallel lines or intersecting lines and transversals. So we got to kind of make sure we have all the right information, and we're going to ask we'll talk about what lines are creating the thing as well. So lines 10 and line 16, so angle 10 and angle 16. If I look here, I have angle 10 and angle 16. So the transversal I'm looking at is transversal Q. So I've crossed line N and line L on transversal Q. So they're outside the lines, so that tells me that they're exterior lines. And they're on opposite sides of the transversal, so that tells me that they are alternate exterior angles. Oops, sorry. So these are alternate exterior. So you can just kind of abbreviate it alt X. Make sense? Change up my color here. We'll do 12 or 14, oh, I'm sorry, 4 and 12. So I look at 4 and 12 here. I have 4 here, 12 here. So now we're looking at N being the transversal, crossing P and Q. So if that's the case, these here now, I am in the same location to the line compared to the transversal. So these are now corresponding angles. Does that make sense? All right, change my color up again so we can see it again. Here we're looking for 12 and 13. Kind of circle with the green on the inside. So I have 12 and I have 13. Again, we're back to the transversal Q and lines N and L. I'm on the same side of the transversal, so that tells me they are consecutive interior. Does everybody see that? Does that make sense? All right, last one. I'll change to purple. Here we have 3 and 9. So again, I look at angle 3 here, angle 9. Again, I'm back to lines P and Q cut by transversal N. We are on opposite sides of the transversal, inside the lines. So that makes them alternate interior. Did everybody catch that? Was there kind of just piecing it together, seeing where they are? You can kind of flip back through your stuff, flip back through the video, and see how you did. Here's a slide for you to do. I give you 3 examples where you have to identify the transversal that connects the 2 angles. So what is the transversal that's cutting across the 2 lines is what we're looking for the first 3. Then for the rest of them, I want you to tell me what type of relationship do they have. Alternate interior, alternate exterior, blah, blah, blah. So go through, take a few minutes. It's going to take you a little while to kind of piece it all together the first time. Enter your answers in the Edpuzzle, and then come back and check and see how you did. All right, so I plot them all up here at once. The lines that are the transversals are Q, L, and P for 1, 2, and 3 there. And then as we go through from counting in order, 4, 5, 6, 7, 8, and 10, they're corresponding, 4 and 5 are corresponding angles based on how they appeared. 6 was an alternate exterior angle because they're outside of lines N and L, which is what was creating the transversal is P. Then we have another corresponding set with 3 and 11. 8 was consecutive interior, 9 was alternate interior, 10 was interior, alternate interior, 11 was consecutive interior, and 12 was alternate exterior. I hope everybody was able to piece that together. If you're confused on that, we'll definitely go over it again as we do some stuff and go through this, okay? All right, so that was just like general two lines that crossed by a transversal. When we're crossing parallel lines with a transversal, the angle pairs take on a little bit added meaning, which is where we'll do a lot of work. What you'll see when you talk about parallel lines is there are going to be two lines that are going to have these like extra set of arrow heads on them, I guess. That's what's indicating that lines M and N are parallel. Again, you can never assume they're parallel unless they have those extra arrowheads or extra arrow things on them somewhere in the diagram. What these do now is we still have all our relationships. 1 and 7 are alternate exterior, 2 and 8 are alternate exterior, 3 and 5 are alternate interior, 4 and 6 are alternate interior, 1 and 5 are corresponding. All those relationships still exist. What they bring on additionally with parallel lines is all of those angle relationships now are going to be congruent. So corresponding angles are congruent. Just think of it if we kind of drew a line through here and was able to somehow slide line N up over line M, angle 1 and angle 5 are going to have the exact same measure. They have the exact same location. They have the exact same measurement. So they become congruent angles. Same thing with alternate exterior and alternate interior angles. They become congruent as well. And again, the vertical angles are always congruent, so we're not really worried about that. The other thing that we need to remember is the consecutive interior angles now are going to be supplementary because they're forming a linear pair when you think of it. Angle 2 and angle 3 form a linear pair with this line here and the ray. So they're going to have to add up to 180 degrees because linear pairs add up to 180 degrees. It's the information you're going to need to kind of solve some problems. When I start throwing equations in here for you and tell you to solve for the value of x, you need to remember what the relationships are between all the parts of all the different angles. Which is what the example is. So we're given that angle 1 measures 105 degrees. I'm going to erase my lines here. I'm going to change my color. I'm going to start working on this problem. Angle 1, they tell me, is 105 degrees. Before I even kind of look at our examples here, I'm just going to go and I can like kind of plug some stuff in here before we even get going to figure out what we want to do. They're asking for angle 2 first. So I look at angle 2. Their relationship for angle 1 and angle 2 really doesn't help me if I don't remember it right away. What I do know is that angle 3 is the vertical angle of angle 5. So that makes angle 3 105 degrees as well. Does everybody see that? So I'm going to start. So I've done angle 3. I also know now from what I know about my consecutive interior angles being supplementary, that's angle 3 and angle 6. Well, angle 3 and angle 6 have to add up to 180 degrees. If one's 105, the other one has to be 75. So now I know angle 6. I'll write it in. This is 75 degrees. This one was 105. So now I can look and think, oh, wait, there we go. 6 and 8 are vertical angles. Vertical angles are congruent. So angle 8 is 75 degrees as well. Then I kind of start looking and say, okay, wait a minute. Angle 2 and angle 6 are corresponding angles. They're in the same location relative to the line and the transversal. So that makes them congruent. So that makes angle 2 75 degrees. Is that making sense? And then I can go back now. Angle 4 is a vertical angle to angle 2. So that makes angle 4 75 degrees. 4 and 5 are consecutive interior angles. They're supplementary, makes angle 5 105 degrees. Angle 7 is the vertical angle of 5, makes angle 7 105 degrees. That makes sense to everyone. That's how you kind of piece together and try to figure it out. There is a problem on the tests coming up that's interesting the way the question is asked with the diagram to try to figure out all the angle measurements. It is something that I know you're going to be able to do. It just takes a little bit of work trying to piece it all together. All right, so your turn. 4 lines crossing. You have to determine, are any of them parallel? Can we figure that out? From that, then, can we piece together all the other angle measurements and come back, see how you did, and then come back and check out your work, because they are a little bit tricky, but you are able to do them. Okay, here's what you should have had. Angle 9 and angle 1 are corresponding angles. So then I can say angle 1 and angle 3 are congruent. Angle 1 is the same as angle 9, so that makes that 80 degrees. Makes angle 3 80 degrees. 3 and 12 are supplementary. That's how we get the 100 degrees there. It's 80 plus 100. So that gives us angle 12. I've already said angle 1 was 80, so we're good there. Angle 4 kind of works out. It's the corresponding angle to angle 12, which we already said was 100. So then that one has to be 100. And angle 3, again, vertical angle to 1, makes that 80. So it kind of worked that one backwards the way I explained it out, but that's how we got that. So then they tell us angle 5 was 68, so that makes this 68. Then they asked us for angle 7, which makes that 68. And then our last one is angle 16. Again, we're looking at consecutive interior angles with parallel lines, have to be supplementary, has to be 112 degrees. Does that make sense to everyone? Okay. Another one I want you to work on. Much busier picture. Tell me what type of angles these are as pairs, and see how you did. Enter them in Ed Puzzle and then come back and see how you did. All right, so there are your answers. I'll give you a few minutes to check to make sure we got them all right. I think I might set those up as, yeah, talking to myself. Sorry, everyone. All right, so that's the end of the thing. There is a homework out on Google Classroom for this, because this is a very important piece of stuff that we're going to need to work on. It'll tie in with the homework from Friday. Should piece it all together so you'll know all the different angle measurements and relationships and everything we need to know to move on later on in the triangles, which will end up having all sorts of crazy stuff you'll see there. So I hope everybody enjoyed the lesson. It was made sense, and I will talk to everyone on Tuesday.